Hi, I'm Scott Hunter, Director of Program Management for .NET. In this session, you're going to see some of the awesome new things we're working on for .NET 6, so you can build cutting-edge applications that target any operating system with the best performance and productivity. .NET is a modern open-source development platform for building many types of applications for many operating systems and devices. With .NET, you can use multiple languages, editors, and libraries to build for the web, mobile, desktop, gaming, IoT, and a whole lot more. .NET makes you more productive building feature-rich applications of any type for any device with great performance. Today I'm going to show you how you can build apps for the future with .NET. But first, I'd love to highlight some of the big accomplishments we've made with the .NET community. The .NET ecosystem has seen some significant growth in the last few years. There are now over 5 million monthly active developers in the Visual Studio family of tools. .NET Core has ranked #1 2 years in a row as the most loved framework on the Stack Overflow Developer Survey. The Cloud Native Computing Foundation tracks the highest velocity projects of all of GitHub. They measure this by the rate of pull requests and issues come in and how many are accepted. The .NET repos have been consistently in the top 30 since 2016 and is currently listed as #1 most active org. C# is the top 5 language on GitHub, an indicator of a healthy open source ecosystem. And .NET contributors are extremely proud of their work on performance. ASP.NET Core ranks at the top of the industry standard Tech and Power benchmarks, an independent open source set of web performance benchmarks that measure dozens of languages and application frameworks. And all of this is possible because of open source collaboration. As you can see, the Tech and Power performance comparison with Java and Node.js. Better performance leads to lower compute cost, and .NET gets better every release. .NET 5's web framework, ASP.NET Core, is over 10 times faster than Node.js, and gRPC server performance is faster than Go, C++, and Java. I mentioned over 5 million monthly active .NET developers all up in Visual Studio. But we're also continuing to see a great adoption of our latest releases of .NET. In the first 6 months of release, .NET Core 3.1 had 3 million downloads, and it was the fastest adopted version of .NET at the time. I can now say that in the first 6 months of release, .NET 5 has 3.6 million downloads, and it is the fastest adopted version of .NET yet. We hear from customers that they are moving to .NET 5 because of the value and performance it brings over any version to date. So why .NET 5? Applications built with .NET 5 can be deployed side by side on Windows, Mac, or Linux, with or without containers, allowing you ultimate deployment flexibility. We continue to make significant performance improvements up and down the stack so that native client app and cloud web apps perform great. You can also reduce infrastructure and hosting costs, particularly on Linux. .NET 5 and beyond is where we are making the investments in the platform in the open with the help of the community. This includes modern innovative languages and APIs, which make it the logical choice for any .NET application going forward. To help you, we're building the .NET Upgrade Assistant. It helps you modernize older .NET Framework codebases. It's a command line tool that gives you step-by-step instructions for upgrading to the latest versions of .NET. It will analyze NuGet packages and understand where your dependencies are. It gives you recommendations and fixes for project files, configuration, and source code to help you incrementally upgrade at your own pace. Multiple project types are supported, including ASP.NET MVC web apps, Windows Forms, WPF desktop apps, and console apps and libraries. And additional project types like ASP.NET Web Forms are coming later. The .NET Upgrade Assistant is in preview, and it's open source and accepting contributions. We're targeting a release for .NET 6 in November, but we're seeing customers use it very successfully today, and I encourage you to give it a try. Now let's talk about where we're headed. Our vision for One.NET is to simplify the platform and choices for .NET developers and provide a single stack that supports the best breed solutions for all modern workloads. In .NET 6, we'll finish the unification of .NET by bringing the AOT workloads that are supported by the Mono runtime to bring one unified SDK, base class libraries, and toolchain. We'll provide a native cross-platform framework for building apps for Android, iOS, macOS, and Windows with a single code base as an evolution of Xamarin. We will also continue investing in cross-platform web UI stack by expanding on the capabilities of Blazor. We're also making it much simpler to build cloud-native apps, and we'll continue investing in performance, not only at the runtime, but also at build time, so you can build and debug apps quickly and iteratively. Here are some of the big investments in .NET 6. I'm going to have the team demo a few of these in a minute, but I want to call out that there are a lot of improvements we're making with the open source community up and down the stack. C#10, the next version of the language, will release with .NET 6. It has strong focus on simplification and improves the way you write code by eliminating overhead and boilerplate. You'll be able to create cross-platform native mobile and desktop apps with a single codebase with .NET MAUI. Blazor is expanding to native desktop capabilities, particularly important for desktop scenarios. We're making it faster to build web APIs with minimal code, perfect for apps built for the cloud. .NET 6 will support more device targets, single file deployments for Windows apps with up to 50% smaller size. And we have productivity enhancements like hot reload. And of course, more performance in the runtime. In .NET 6, one of the areas we focused on better performance was Entity Framework Core. We aspire to be one of the best performing .NET data access layers. Dapper, for example, a lightweight .NET micro ORM, gave us lots of inspiration for this performance effort. I'm super happy to report that EF Core performance is now 70% better than on the Tech and Power Fortunes benchmark. And the memory allocations have been reduced significantly, up to 43%. A lot of this is due to performance work in .NET 6 runtime, but EF Core 6 itself is also 31% faster in query performance. These tests were done in-house on the same hardware as Tech and Power. Similar results should be reflected in the next round of the Tech and Power benchmark for the Fortunes test, which includes database access. Now let's talk about C#. From now on, we'll release a major version of C# every year along with each version of .NET. This allows us to ship small features more quickly, giving you better value. C#10 has a strong focus on simplification. Features like global usings and file scoped namespaces remove much of the boilerplate code you must write today. There's also a lot of small productivity features that are about improving the clarity and simplicity of your code. We've released a solid core of records features in C#9. In C#10, we expanded in ways that people have been asking for, letting records be declared as structs, allowing properties to be declared required, and more. We've also made improvements to lambdas and auto properties. C#10 will release with .NET 6. I'll hand it over to Dustin and Mads to show you some of the awesome new C# features in action.
Hey again.
Hello.
Once again, I'm here with you, Dustin.
Yes, and I'm here with you, Mads.
Another set of C# features. Today we're looking at C#10.
Yeah, and we're starting from where we left off from last year with C#9, from the records demo that we demonstrated last year, right? So this is kind of like the very end of that.
Yeah, we have the records feature at the bottom there, which is a record declaration is really a class declaration with some extra bells and whistles that make it more value oriented. So if you look at the code above on line 10 there, for instance, because it's a record, it supports the with expression, which is, fancily called non-destructive mutation. I almost couldn't say it. It's that fancy. Non-destructive mutation, where the with expression creates a new object that's just like person, same type, same values and everything, except for what's in that object initialize. Then we have a toString that is value-based. It prints out the contents nicely instead of just something unreadable.
So they look good in the debugger and that sort of thing, right?
Yeah. But then a more important thing perhaps is that the equality of a record is also value-based. So equality works by delegating to the equality of all the members of the state. Like if each of the fields inside are the same, then the two records are the same. And just to make sure you get the right equality, we also override the equals operator to be based on that rather than on the reference comparison.
Yeah, and these work because person and original person have the same state inside of them, right? They both have these two values because we spaced original person on other person and changed the name back. And so these actually return true.
Yes.
If I were to put them on the print true at the console.
Different objects, same state.
Yeah.
So you get the idea. But we want to do some more stuff with records. And so the first and maybe most important feature that we added in C# 10 is that you now get to say record class person. And what that means is exactly the same as before. This adds
6
nothing.
characters more.
It adds nothing to what you can express in C#. So the point of allowing this really is that, of course, you can put something else instead of class. You can now say that a record is a struct. By default, it'll be a class, but if you put struct, you'll get a record struct instead.
Yeah, and so that means that all of this works exactly the same as before, but now it's not heap allocated.
Yeah.
Right. Yeah.
And one thing that's very interesting is that many of the things that you do with a record they're value based, but so are structs in general. And so structs don't have an equality operator, but they do compare. All structs compare equals by value.
Right.
And all structs are able to copy themselves. That's just what happens when you assign them. That's just how they work. And so we can easily support. It's easy to support the with expressions, and we can support them not just on record structs, but on all structs, just because they can use their innate ability to copy themselves.
Right. And so this works really similarly as before. The big deal is that actually toString is different. If I recall, that says the value types do toString a little bit differently than records, if I recall.
Yeah.
But also, value types don't have equals. I'd say, but they are very similar to structs, to records classes, in that this is going to give me back another person, but with the same state changed as it did before. Exactly. So it's pretty cool. And because it works for value types, it also means it works for tuples or any sort of struct. It works for any sort of value type.
Yes, with expressions on all structs.
Yep.
So that takes us to another area that we tinkered on in C# 9, which is that object initializer up there in the beginning, which is, that's object initializers have worked for a long time, but we started making it so that they are more full-fledged feature, if you will, more well-rounded. So in C# 9, we made the init accessors, which let you say that it's like a setter, but it only works until the end of the object initializer. So you can use an object initializer to initialize an object, and then it's immutable from then on. But we want to continue this evolution of what you can do in object initializers. And one of the weaknesses they still have is that you don't have to initialize anything. They don't make you initialize anything.
Yeah, there's nothing that stops you from using it this way, and now passing in nothing at all, and it would be set to null.
Right. I would like to, in this case, I would probably want to be able to require the person initializing the record or the type in general to provide these in an object initializer. And in C# 10, we're going to provide the ability to put the required keyword.
Yeah, something like that. It doesn't work today, so we're getting squiggles in the editor, but that's what it'll look like. And you can say these are required, and so that means, and there will be tracking for them, so you can require that they're either assigned during an object initialization, or that constructors must assign them, and those sorts of things. So.
Yeah, for this and the next couple of features, we haven't actually implemented them yet, but we'll still show them to you because that's fun, right?
Yeah. So another feature that I'm personally very excited about, especially as we're talking about properties, is the ability to do more with these auto-implemented properties that we introduced in C# 3. I think you've referred to it as the cliff, like the property cliff, when you have an auto-implemented property and you just want to do one little thing, one extra little thing, and that causes you to fall off the cliff, create a backing field, add a body for the getter and the setter, and do the whole thing. And that, we call it the cliff because that's a really unhappy moment when I'm coding.
Yeah.
And maybe all I wanted to do was, when we were initializing this, just make sure that the value was trimmed, the white space was trimmed off of it.
Yeah,
Um,
yeah,
and so in C# 10, we're going to let you do that, and it'll look something like this.
exactly. We are letting you refer to the generated backing field of the auto property with a new keyword field. We're letting you do that in both the getter and the setter. In fact, you can specify both, and now it just looks like an ordinary property, except you're referencing the field from within them, so we generate one for you.
Right.
And that means
And
that
so,
as long as you have a backing, as long as you are happy to have a backing field that's the same type as the property, you can get it automatically. You don't have to declare it.
right. And that means that the properties themselves become better encapsulated, right?
Exactly.
They hide the data that they're using, and you can guarantee that, access to that field only happens through the property. And that's, that just makes your code better, safer, cleaner.
Yeah.
And you type fewer characters.
Shorter and safer. What's not to like?
Yeah, that's beautiful. Speaking of shorter and safer,
Ah,
this is another feature that we've been looking at. We've talked about this now for a while, but it's this problem where I've actually lost many days of my life writing this one pattern, and it'll resonate with most of you, I'm sure, where you say, down here at this write to file, if I say the first thing I might write in this method is if file path equals null, throw new argument null exception and pass in file path as the parameter name.
yeah.
And that's something that takes away life. And we want to give that back, right? We want to, again, allow you to be very brief and state your intent very clearly.
Yeah.
And so we're introducing in C# 10 a feature we're calling null parameter checking, which will do exactly what I said. The code that I described, it'll introduce that for you. So if you type bang, bang, exclamation point, and that then allows me to leave this method as an expression bodied member, but it'll still introduce that argument null checking for me on the parameters where I specify this. This is a beautiful, beautiful thing.
Yeah. I mean, this is especially on public surface area. This is a place where nullable reference types only got you so far, right? Because you'd still be, if you don't want a null to come into your method, you'd still be relying on the caller doing their null checking for that to sort of be fully safe. And that is not always the case. So you still want to check for null on the incoming, and this lets you do that with 2 characters instead of a whole line of code. So
yeah,
you're welcome.
Excellent. You're welcome. All right, let's get back to no squiggles, and let's look at some features that are actually implemented here. Okay. Now, last time we moved this file into top level statements, which really removed a lot of boilerplate. But there's one thing here. I mean, so this is all the main method, and I've got a type down here. Now I like to have all of my types in one type per file. So I'm just going to cut this out, and I'm going to add this to a new file. I'm going to create a new file here. We're going to call it person.
Good
and
choice.
I'm just going to grab that and yes, thank you. Got a lot of experience in naming these files. So, but also my experience tells me that I'm going to be frustrated right now because whenever I had to do this, and the IDE helps a lot these days, but whenever I've had to do this manually, I now have to figure out which using directive to bring along to make my code compile. And helpfully, right?
Yeah,
put
the
in
template
a bunch that I don't need.
The template gave you 5, but not the one you need. Yeah.
Yeah. And so and then we call this the kind of the using directive gymnastics, where you have to, literally do somersaults and tumbles to get things back to a compiling state.
Really, it'd be much better if you just had the same usings available throughout the whole project in all the files. It's rare that you want to leave some usings out. The only reason you clean them up is that they take up so much darn space in the beginning of your file.
I happen to have this very suspiciously named file, demo file here, where it has all the using directives that are declared in other files. And you see they're not used right now because they're not. Right? There's nothing in this file that uses them. But if I put the global keyword in front of all of them, 2 of them light up because now these are used elsewhere. They're used in person for system IO and console in program.cs. These now have warnings because they previously appear. they're as global using. So you can get rid of these because if you want to think of it, a good way to think about this is that it's as if we took all those global usings and we pasted them at the front of every
Right.
file.
Global
Okay,
using
and
simply means applies to every file in the project, not just the file
right,
they're occurring. And we just recommend, as a good practice, putting them all in one file to the side, like that one. You'd call it usings.cs or something. Who knows?
yeah,
And yeah, we need to add the namespace that you put
yeah,
your person
that's the root namespace. So I figure I'll just put
person
that right there.
declaration in there.
So that is now beautiful. Now this is our main file. This is all of our main program.cs code. That is gorgeous.
That is
I love
slick.
it.
You really help clean up so much vertical waste there, getting rid of the usings. Now, looking at this declaration, though, there's still some horizontal waste going on. I mean, every namespace, almost every declaration in the world is in a namespace, and every namespace moves the rest of your code in 4 spaces. Can we just get rid of that?
Well, I think I could get rid of it. I don't, it'll compile if I put a semicolon usually.
Yeah.
So yeah.
There you go. Namespace, semicolon, the namespace directive, file scoped namespace, as we call it. That's a namespace that applies to the whole file. Like 99.9 files in the percent of files in the world, there's just one namespace in that given file. Let's not complicate things. So
yeah. And so now this is just as beautiful as this.
Yeah.
I'm really pleased, and all the usings are over here, and the project is organized beautifully. So
yeah, I think we really organized the files beautifully. And with that, we'll hand it over to the next demo. Thanks, Dustin.
Thank you very much. Thank you, Mads.
Thanks, guys, for those awesome demos. Now let's talk about what we're doing to make it faster for you to build for the cloud. For .NET 6, we're building upon C# top-level programs to provide you with a lightweight way to build ASP.NET Web APIs with minimal code. No usings, no class definitions needed. This is an easy way to build APIs that can immediately take advantage of cloud scale without all the ceremony and boilerplate code of traditional controller-style based web APIs. And when your project starts to get too big, we'll provide tooling to automatically convert these to ASP.NET MVC controllers. It's just another option for quickly building APIs that don't need all the bells and whistles of controllers and startup classes. And they'll be part of .NET 6. Next, I'd like to hand it over to Maria and Stefan, who are going to show us how we can build minimal web APIs in .NET.
Thanks so much, Scott. Hi, everyone. My name is Maria Nakaga. I'm a senior program manager who works on .NET Minimal APIs.
And I'm Stefan Halter, a senior dev on ASP.NET.
So briefly in his presentation, Scott talked about the new .NET Minimal APIs that we can expect in .NET 6. So I'm going to switch over to my desktop so we can show you what we're looking at. Now, Stefan, when I look at this, the first thing that stands out to me is that there's no startup.cs. And from what I understand is that startup.cs is now optional and can always be added back in. But I'm going to look over here at my program.cs, and from the get-go, like the first thing I have to ask you is, where are all my namespaces?
So this is relying on a bunch of cool new C# 10 features, and the usings are unnecessary because in .NET 6, we are including global usings by default in ASP.NET Core projects. There are a lot of usings that happen to be in just about every CS file in an ASP.NET project. And we think that when you're writing these smaller kind of APIs, that they're not necessary. It's also using top-level statements and new features that make it easier to use lambdas.
Oh, so something like this.
Exactly, like that hello world right there.
All right. So if I run this application, it should run because I know we're working on like nightly builds. So I'm just going to give it a try.
Cross your fingers.
So over here in my other window, it just popped up. I have a Hello World app in just 3 lines of code. This is pretty amazing.
Isn't that crazy? I sometimes hardly believe it myself.
So I should be able to define multiple endpoints, correct?
Absolutely. I sent you something earlier that kind of shows that off.
Okay. Let me grab that. I'm going to head back to our minimal app here. Right, and this is what you sent me. Okay, this looks pretty cool. So if I run this and then I go to /plant, I should see a return, right?
Exactly. So this is different than the type of map-get you've probably seen before, where you have to do complicated things with an HTTP context. This accepts just about any kind of callback. It's a lot like a controller action. You can just return an object, and it'll be written to the response.
Okay, so let's go take a look at that. I'm going to switch back to my browser. And if I do /plant, there's my response. So when I look
That
at
easy.
it was that easy. So when I look at things like this, I can imagine them being really great for smaller applications and smaller microservices. And I know we've been working, specifically you have been working on a minimal weather API. And I think you sent that to me as well. So I'm just going to switch over to that. Stefan, I see a couple of different projects here.
Yeah, so I wrote this same application in ASP.NET and Node.js using Express. And there are two ASP.NET versions, one kind of the web API way and one using the new minimal API. And this is for comparison purposes, but this is the kind of app that I think a lot of people reach for micro frameworks like Express for. And let's open app.ts, and I think we'll see why. So what do you think of this?
So the moment I look at this, I can see in just a single file, I'm able to build an API that other applications are actually able to consume. And it's all happening in just 37 lines of code.
Yeah, I think that when you're trying to create a simple application like this, something like Express is super appealing because you don't need to write a bunch of code just to define a single endpoint that might query an Azure backend and combine some responses like this does.
So should we go have a look at what this looks like in minimal APIs now?
Let's do that.
So, okay.
So you'll notice that this looks fairly similar to the Express version, and that's because we removed a lot of the ceremony that you typically see in an ASP.NET Core application. This gets straight to defining what you need to implement an endpoint that queries the Azure Weather Service and returns a response. And you'll notice, unlike in the earlier 3-line sample we were looking at, this time we do have a builder. And on the second line, there's a builder.services, which gives you the iService collection that you know and love from configure services. So a lot of the capabilities are there, but they're not in your face. They're there when you need them and out of your way when you don't. And one of the other key differences between this and the Express app is we have a strongly typed weather model. That you don't see here, but it provides some advantages. It allows you to structure the output. And I think that it's something that makes the ASP.NET Core app even better.
So I know that you have deployed this to Azure. Before we go through that process, do I need to make some changes into our file so we can trigger the action?
Yeah, let's make a change just to show how our deployment pipeline works. As a developer, GitHub Actions are one of my favorite things. I don't like having to use a UI or go into the Azure portal every time that I want to deploy an application. This allows me to just git push and my changes are there.
Okay, so I hit publish. So once I've hit publish, what this will do is trigger an action using GitHub Actions, which is part of my CI/CD pipeline. So if I do go over to GitHub right now, where would I see this working?
So you can see it right in my minimal weather GitHub repo. There's an Actions tab where you can see the progress right now.
Oh, there it is. So it looks like it's successfully deployed. So if I go over to my endpoint in Azure and you gave me a URL earlier, I should be able to see the changes I just made. And there you have it. And there is our brief introduction to .NET Minimal APIs. Thank you so much.
Thank you, Maria and Stefan. Next, I want to talk about .NET MAUI. We've been shipping the first previews of .NET Multi-Platform App UI that we announced a year ago at Build 2020. .NET MAUI is the evolution of Xamarin Forms, designed to help you deliver high-performance, cross-platform, native desktop and mobile apps, all from a single codebase. In Preview 4, you can now use Visual Studio to build .NET MAUI apps. .NET MAUI under the hood uses technologies out there today for building native apps on Windows with WinUI, Mac Catalyst for Mac OS, and of course iOS and Android. .NET MAUI abstracts all those frameworks into a single framework built on .NET 6. .NET MAUI on Windows will support WinUI and Project Reunion, allowing these apps to use all the newest native features on supported versions of Windows 10. That means you can build all these apps for any device from a single codebase and project system. Instead of learning different stacks and languages for each, you can choose one language, one set of libraries, and one UI stack for all of them. And that includes desktop and mobile apps, Windows, macOS, iOS, Android. It will release as part of .NET 6 in November. You can watch the progress and help contribute on GitHub in the .NET/MAUI repo. Let's see a demo of .NET MAUI in action. David, take it away.
Hello everyone, my name is David Wertnow and I am a program manager at Microsoft working on .NET and .NET MAUI. I'm excited to be with you today to introduce you to .NET MAUI for building native Android, iOS, macOS, and Windows applications. You can make them as consistent as you need or make them as platform specific as you need. All the power is in your hands and I'm going to show you some of that today. So let's take a look at just how easy it is to get started with a .NET MAUI application. We're going to use the command line to do a .NET new MAUI. I'll give it a name of Hello MAUI. So this is going to scaffold out a template project for us. In the future, you'll of course be able to do this from Visual Studio, File New, but it's nice to see just how easy it is from the command line as well. And if we look at the Hello MAUI folder, you can see that we have a couple of folders in here. We have Hello MAUI multi-targeted project for all of our code, and then we have a couple of WinUI 3 projects. We'll talk a bit about those in a moment. So let's go ahead and use Visual Studio, our favorite editor, to work with this solution. And then we'll walk through some code, we'll build and run, and then we'll look at some more complicated examples with our weather application. So as this loads up, the first project that you see here, Hello MAUI, I'll go ahead and set that as the startup. This is our single project with multi-targeting support. It has resources for images and fonts all in one place. And all this code is completely shared across all the different platforms. And then you can, of course, code your platform-specific things in this project as well. In the near future, this first WinUI 3 app project is going to get folded in here so they can sit right alongside the Android, iOS, and Mac Catalyst. And then the packaging project we're working on removing from the solution when you don't need it. But for now, those are here, and we're working through that. So let's take a look first, now that I've selected the project. How can I run this? So the first thing I need to do is come up here to my Run menu and choose the framework that I want to build for. So I'm going to build for Android. I'll select Android here, and then it populates the Run menu with my different emulators. I am going to go ahead and choose the one that is already up and running, and I'm going to build and run that. So once that's up and running, it'll pop up for us. While that's happening, let's talk a little bit about what's in this resources folder. So traditionally, when you're doing multi-platform development, you need to go figure out how each platform prefers for you to wire those things up: fonts and images and media assets, app icons, splash images. Well, we have all that stuff in one place for you right here. So you can put your fonts in here. You can see that this is of type MAUI font. You can put your images in an images folder. They take the type of MAUI image. And then we also have app icons and splash screens. If we look at our CS proj, just to kind of show you behind the curtain how this stuff looks, you can see that these things are all wired up. And as a matter of fact, the fonts and images folder are using a wildcard. So anything you drop into those folders is going to get picked up and used. All right, now we're up and running with our demo application. So this is the new template for .NET MAUI that we have right now. Of course, we have a counter. This is the main page, and we know that because main page is right here. And I can say, hello, MAUI, typing. And so we have XAML hot reload as well as C# hot reload, which we're going to show. I'll show for you in just a minute. And you can quickly and easily iterate over your UI without having to stop and build and stop and build and redeploy and all that. Saves us a ton of time. One last thing I want to walk through before we leave this project and go look at something a bit more complex is exactly how things get wired up from the native layer all the way up to the cross-platform. So we can look at the app delegate, for example. This is the UI app delegate that iOS and macOS uses to bootstrap their projects. So this is the C# implementation, and we have our own version here, the MAUI UI app delegation delegate. And it is going to create the host builder. And we're passing in our startup class so that we can interact with it from one single beautiful location right here in the startup CS. So for your applications, this is the one place that you want to be aware of where you can register fonts, you can register for compatibility things, and we'll look in just a moment how you can actually wire up for lifecycle events and do all kinds of other configuration right here without having to go find the platform-specific places to do it. Super productive and convenient. And then once this use MAUI app calls the app, we can jump over to our app. And you can see that it does have XAML, where you can initialize resources and dictionaries and themes and things like that. But the main job of the app is to create windows. So .NET MAUI, as opposed to Xamarin Forms, which is the predecessor that has been around for 7 years, and Xamarin for years before that, didn't have multi-window support. .NET MAUI does. As we are extending from mobile into desktop, we're embracing all the desktop-specific things that you need to be able to develop real native applications. So we have a couple of calls here that are going to be removed. So you're seeing some code in transition. But this does some compatibility initialization, and then this call here is setting the initial image directory for when you're running on Windows. So while this is going to go away, this API is a great example of just how flexible it is in .NET MAUI for you to be able to call into platform-specific things when you need to without having to go anywhere else, create a bunch of classes and things like that. And then, of course, the main job of this method is to return a window, and it's going to return the main page that we've been working with. So this is cool and fun, but let's look at something a bit more complex and show off how we can do more advanced things. So let me minimize this and let's take a look at the weather app. So this is a demo that we put together just recently. Shows off some different weather UI. You've got some hourly forecasts here. You've got daily forecasts down here. You can even see what your highs and lows are going to be, that sort of thing. We've got a favorites with all the different locations that are in the app. We also have weather with a built-in map using a web view, and then we've got some settings back here. So I want to take a look at this favorites screen, and let's talk a little bit about how controls are realized on the native platforms. So we have the notion of a handler. In previous iterations with Xamarin Forms, we would call things renderers. And we learned a lot about that architecture over the past 7 years, including how to improve it. So handlers is based on all of that learning. And it's really about making it very easy to extend controls and also making them extremely performant. So we want to make sure that your apps are as fast as possible. Here you see on the screen the favorites page, and I'm in the C# because I want to hook into some handler registration and override things. So I am accessing the view handler. Each control has its own handler, and then each handler has a mapper. Mapper basically says, hey, what's the property that you want to implement in a cross-platform fashion? Here is the method that is going to implement that on the native platform for each platform. So we end up with some very easy to write, bite-sized things. I love it. I love it. So here in this particular one, we're overriding background color on all views. And in particular for Android, I am accessing the native view, setting the background color to a random color. And in this particular case, my random color method that I wrote down here is returning a color object from Maui Graphics. Cool graphics library that we now have. And then we're sending this color to the native type of color that Android expects. I have some pre-selected colors here that we're going to choose from. Now you notice that none of this actually was implemented here, even though background color clearly is set in the Android emulator. It's because I haven't actually done anything with it yet. So if I come in here to this register handlers method, and I uncomment that, hit the fancy apply code changes button. Now, when I navigate back and then forward again, you'll see that, now I have all those beautiful random colors applied. This is a useful technique to just figure out what are the bounding boxes for all the different things. For example, here, the USA on the Nairobi, which Nairobi is not in the USA. You can see that it's actually taking up a whole lot more space than I would have expected. So, or it could be that the view behind it's also using the same green. Something to figure out. But that it could be very useful for determining what's going on with your layouts. So if I back up here and then I start going back to some pages, you can see that that is applied across all these different pages because they all inherit and use that same method. We also have examples in our repository where you can use this to improve your accessibility and your UI testing, as well as doing things like overriding particular controls like the entry on Android and removing that underline. All right, so that is a bit about the architecture of handlers. Let's go look at the startup class in this particular application and talk about some of the deeper native integrations for the platform. So this startup class is a bit more complicated than the one that we saw in the template. In particular, we have some more fonts being registered here, and we're configuring some services. So we have some platform-specific services that we need to use to access things such as the Windows system tray, as well as the Windows notification service. And we do the same thing over here for Mac Catalyst, which I'll show you that running on my Mac in a moment. Another cool thing that we can do here is we can configure native lifecycle events. So you can see that I am hooking in now to Android's native lifecycle events. And anytime that back button is pressed, I'm going to debug and write that out to my console. So I've hit the back a few times. And if we go look at our output, and if I just go ahead and pin this, and I click back, back I went. So it's this back button here that triggers that. Pretty cool. So very convenient, again, and very powerful for you to be able to access anything you need at the native platform. So let's go look at how we are initializing these different platform services and then take a tour of the WinUI application. So in the home page, I just chose this as a convenient spot to set these things up. We're setting up app actions and tray icons here. And we're also doing a little bit of initialization for WinUI. So here in our app actions, we're using the Essentials API. So this is a cross-platform, no UI needed, no platform-specific things needed, to set up some quick actions. And if we look down here at the app icon for the weather app, this one here, when I right-click on it, I have Add Location and Check Current Weather, which are the two app actions, little quick links. Very convenient to add to your applications. And then to put the .NET bot in the system tray, we have this little method here. And when I click on it, for funsies, when I click on the .NET bot, we get a cool little local notification using the platform APIs. And so here is that same application running on the desktop. And you can see that it's resizing nicely. I'm sure that there's more work that we could do there. It has a compass for the wind in case a tornado might be coming your way, I suppose. We have that same grid of locations here. We have the map, and then we have settings. And this is all 100% shared code right here from .NET MAUI running on both Windows and Android. But let's also take a look at this running on Mac OS. So I'll flip over now to my Mac, which is running in front of me, and I am remoted into it. You can see here we've got the Catalyst application, and just like before, it resizes nicely. We've got all the same content, all the same UI running right here. And it uses the native animations to go backwards and forwards. And there will be more work coming as we progress through previews in terms of our navigation pages and things like that. And then this is the same application running on iOS. So beautiful side-scrolling hours of the day, all the native things. And just like before, I can come down here and I can access those quick actions on mobile just like we did on Windows. And similarly, we've got the application running here with Mac Catalyst, and when I right-click on that, I get those same app actions here. And of course, we also have the .NET bot in the system tray on the Mac as well, because it's a .NET MAUI application. And when I click it, I also get a notification here, using all the same native APIs. Very cool.
Thanks, David. .NET MAUI is really coming along nicely. Now let's talk about Blazor. Blazor has become a popular way to write .NET web apps. In fact, it's one of the fastest growing workloads in .NET today. We first supported Blazor on the server, then in the browser with WebAssembly. Now we're extending it again so you can write Blazor desktop applications in .NET 6. This means you can easily create hybrid client apps which combine web and native UI together in a single native client application. It's primarily targeted at web developers that want to provide rich client and offline experiences for their users. Blazor Hybrid Apps is built on top of .NET MAUI. It relies on a UI stack for a native application container and native controls should you want to use them. Blazor desktop apps have full access to the machine. You can do things like call native APIs, access the file system, write multi-threaded applications, all with the high performance and optimal memory consumption you get with .NET. You can't do this with pure web technologies. Although it will run anywhere .NET MAUI runs, for .NET 6, our primary focus for Blazor is on supporting rich desktop scenarios on Windows and Mac. We've also got more features for your Blazor web apps in .NET 6 Preview 4. You can now ahead of time compile your Blazor WebAssembly apps to WebAssembly for significantly improved runtime performance. The download size of Blazor WebAssembly apps is also getting smaller, even though we've added support for over 500 new APIs in .NET 6. Blazor is getting support for error boundaries, so you can better manage and isolate errors in your components. We've also added support for better type inference and generic type constraints in Razor. There's a new dynamic component for rendering a component selected at runtime. When pre-rendering Blazor components from the server, you can now persist the state of those components so it can be reused on the client. We've also been working with the Fluent UI team on Fluent UI support for Blazor based on the official Fluent UI components. ASP.NET Core is our modern web framework for .NET, and it's getting a bunch of new features in .NET 6 too. To call out a few, we've added a new HTTP logging middleware to make it easy to log and analyze HTTP traffic to your app. We added support for async streaming and iAsync disposable to ASP.NET Core controllers. gRPC is getting support for client-side retries and load balancing. You can now use scoped CSS files with MVC views and Razor pages, and we're improving how the ASP.NET Core SPA templates work to better integrate with existing front-end JavaScript frameworks. I'd like to call up Dan Roth, who will show some of the new features in ASP.NET and these new Blazor desktop applications.
Hi everyone. Let's take a look at some of the new features coming to ASP.NET Core and Blazor in .NET 6 for web development. To start off, we're going to do some work on this picture fixer app so that we can display and edit a simple list of pictures. Now, this is a Blazor WebAssembly app, and I've left myself a little to-do here to add the code for actually displaying the pictures. Now, in .NET 6, we can do that using the new support for .NET Hot Reload. I can just change this text right here. Hi there, everyone. And then save it, and boom, it just immediately updates. And it is so fast. Like if I change this again, hi from Blazor, and watch, I'm gonna put the mouse over the save button, 3, 2, 1, save. Almost instantaneously, the text updates. It's great. All right, so let's add a little bit of code here. We're already getting the images from the server, so we just need to loop over them and render them. So let's go ahead and add a little loop right here instead of this placeholder text. Great. And then, as you can see, I'm using this little component, this image list item, to display each image. And that's currently just rendering a div for each image with its name. All right, let's save that. And boom, there are all our image names. Okay, let's try and style a few of these. Let's add the class. And what do we want to do? Let's make the background white. We'll save that. Okay, good. Let's add some padding. Save that. Awesome. Add a little background shadow. Maybe a little bit more. As you can see, this is a fast and fluid way for me to update my application. Now, this isn't a demo on CSS framework, so I'm just going to take some markup that I've already got done here and copy that into the app. There we go. And we'll save that. And there, now we're getting all of our images and their names and their descriptions and a little bit of text that says when they were last updated. Now you can also update your C# code in addition to your markup. This new markup code is using this humanize last modified method to render when each image was last edited. We can edit that. Let me go down here below in the code. Here's the little string it's using to display that text. Let's change this to, I don't know, like last changed. We'll save that, and boom, immediately updated. Now the app is being updated without even restarting it. The code is being patched as the app is running, and the browser isn't refreshed. So any application state that you currently have is just preserved. Lastly, we can also update the styles of this app using Hot Reload. Here's the styles for the main layout of the application. Currently, we have this sort of green color that we're using for the theme. I don't know, maybe we should try out something different. Let's try out red. And again, we just save, and the app is automatically updated. .NET Hot Reload makes developing your ASP.NET Core and Blazor apps much faster and more productive than ever before. Now let's take a look at the new support in Blazor for error boundaries. Error boundaries are components that can capture unhandled exceptions from the component tree and allow us to react to them. To show how error boundaries work, let's introduce a fake bug in our humanize last modified method to throw an exception for a specific image. All right, let's go ahead and save that and hot reload that into the app. Ooh, and almost immediately we see the dreaded yellow bar of death. If we F12 into the DevTools, we can see that our exception is being reported to the browser console. To add an error boundary to our app for dealing with this exception, we can use the new error boundary component. For example, we can go to our main layout and add an error boundary right here. Let me do that. Here's what that looks like. An error boundary is a component, and it has child content. By default, the error boundary will render its child content when everything's going smoothly. But if an exception gets thrown, it will render its error content. The context object is the exception that was thrown. And here I wrote a custom component that renders the details of that exception. Okay, so if we go ahead and save this and apply this to our application, let's see what happens now. So when the app loads and we get that exception, we're now getting our error content showing us the details of the exception. Now, normally we don't want to display exceptions like this to users, and we probably also don't want to have such a broad error boundary in our app that handles general unhandled exceptions. In general, the app shouldn't keep running if we have an unhandled exception of that nature. So instead, let's add a more scoped error boundary to our application. Let me undo this. Go back, and now let's go add an error boundary just for where we're using that image list item component. So let's do that. Let me copy a new error boundary from here and put that in, and we'll save that. All right, let that apply to the app. Cool. So now instead of getting a general error boundary, we're only seeing the error boundary being applied to the specific part of our app that's failing. We can now go in and customize the error content to be specific to our scenario. Instead of using my generic errors details component, let's add some specific markup right there. Add that to the app. And there we go. So as you can see, error boundaries give you a convenient way to manage unhandled exceptions in Blazor apps. Our Picture Fixer app has some basic image editing functionality. For example, let's see here. Let's make this tennis player's life a little bit more interesting by removing the ball. We can select the ball, and then poof, it just disappears. This is an implementation of a basic patch match algorithm, all done in .NET and C#. Here it is. That matches the colors around the selection to eliminate that part of the image. This is actually based off of some code written by this gentleman. Thank you for your contribution to the open source community. All right, let's see what else we can do with this. Maybe we can remove this URL up here. Yeah, gone. All right, cool. Let's see what happens if we try to remove this entire logo. Let's see if my mouse skills can do that. And I think I got clipped a little bit of his shoulder. It's well, yeah, I mean it worked, you know, mostly got it, mostly good, but it did take a little while. It took almost about 10 seconds to do that processing. This is because Blazor WebAssembly today runs on an .NET IL interpreter that's implemented in WebAssembly, which isn't great for CPU-intensive tasks like this. But we can fix that by trying out the new support in .NET 6 for WebAssembly ahead of time compilation. WebAssembly ahead of time compilation will take our .NET code and pre-compile it to WebAssembly so that it runs much faster. Now, to try out WebAssembly ahead of time compilation, what you need to do is you first got to install the optional workload. It's not included in the SDK, you have to add it. Once you do that, then you actually need to publish your application. Well, first of all, you got to turn it on in your app. So if we go to our WebAssembly project, you're going to want to set run AOT compilation to true, and then you're going to want to publish the application. We only run ahead of time compilation on publish because it can take a little while. Actually running ahead of time compilation on this app took about 10 minutes. That's something that we're trying to make better. It will also increase the size of the application a bit. A default Blazor WebAssembly app will get about 2 times larger when you ahead of time compile it. So you're basically trading off load time performance for runtime performance here. And you'll have to decide if that trade-off makes sense for your app. All right, but once you've done that, you can then run the published application. I've got it running here. Let's go ahead and bring that up. So here's our ahead of time compilation, ahead of time compiled version of the app. Let's see that it still works. Can we still remove the ball? Yeah, we can remove the ball. Let's now try removing this background logo again. There we go. Whoa! Oh yeah, that's much faster. So 0.5 seconds versus the 10 seconds that we saw previously. Blazor is getting support for Fluent UI. Fluent UI already has standards-based web components that can be used with any front-end web framework. The folks on the FAST team that built the Fluent UI web components are now also working on Blazor component wrappers for these web components. You can try out an early preview of their work using the Microsoft.fast.components.fluentui NuGet package. Here's a sample app showcasing their components. They offer Fluent buttons, cards, menus, progress indicators, switches, tree views, and much more. Each of these components can be conveniently used as Blazor components in your app. Under the covers, the components render the standard Fluent UI web components, which we can see in the rendered output. To learn more about the new Blazor component wrappers for Fluent UI, check out their GitHub repo at Microsoft/fast-blazor. MVC and Razor pages now have support for CSS isolation. With CSS isolation, you can scope CSS styles to a specific page or view. For example, let's say we want to add some color to this Razor Pages app so that the headings have a different color. We can do that in our app style sheet. Let's do that right here. Change the color to something a little bit brighter. There we go. All right. But then what if we wanted the heading on the privacy page to be different? We could do that using a specific CSS selector, or we can just use a page-specific CSS style sheet. You just define a CSS file following this convention, and now all of the styles we put in this file will only apply to the privacy page. Nice. And the home page still looks the way it was. Earlier, we saw how you can now build minimal APIs with ASP.NET Core that are simple and clean. To help diagnose issues with your HTTP calls, you can now use the new HTTP logging middleware to log HTTP traffic, including header and body content. Let's go ahead and wire that up. app.use HTTP logging. And let's go ahead and run it. All right. So now in our logs, let's pull this side by side. Every time we make a request, we can see all of the HTTP details for each request. ASP.NET Core in .NET 6 is faster and more efficient than ever before. Let's take a look at an example. Here's a simple ASP.NET Core server app that receives new secure WebSocket connections using 0-byte reads. Using a 0-byte read means the connection can be received without having to allocate any memory up front. 0-byte reads are now used throughout the ASP.NET Core runtime, dramatically reducing the amount of memory used. All right, let's test this server out on .NET 5 first, using 10,000 concurrent client connections. Start the server, start the client. On .NET 5, the server uses almost 500 megabytes of memory. Okay, let's now try with .NET 6. Start the server again, and we'll start the client. Yeah, that looks way better. It uses about 150 megabytes less memory, about a 30% reduction. Nice. ASP.NET Core and Blazor are great for building web apps, but sometimes you need more than what the web platform offers. In .NET 6, you can combine Blazor with .NET MAUI to build hybrid desktop apps that reuse your existing web UI code and web development skills, while enabling full access to the native capabilities of the device. Here's a version of our weather app implemented in Blazor for the web. We can see the current weather and check out the weather at other locations. Here's the code for the weather application. There are all of our Blazor components in this shared Blazor weather project. To reuse these components in a .NET MAUI application, we use the built-in Blazor Web View control. There it is. And then you can just reuse your existing Blazor components directly, unchanged. As you can see here, we're referencing the Blazor Weather project directly. Here's our weather app now running in a native Windows application. You can see it has the same look and feel and exactly the same functionality. And that's because it's reusing the same code. The Blazor Web View will run our components directly in the .NET process and render them to an embedded web view. WebAssembly isn't involved at all. This means our Blazor components run fast and can access native functionality through the .NET platform. For example, we can reuse the system tray integration that we saw earlier and trigger native platform notifications. There's our little .NET bot down in the corner. Let me click him. Yeah, awesome. Blazor hybrid desktop apps running in .NET MAUI can run anywhere .NET MAUI can. Let's switch over to my Mac and to see how my Blazor desktop app can run across platform. All right, here's our Blazor weather app running as a native app on a Mac. As you can see, it's got the same look and feel, it's got the same functionality. If we want to go check out the weather in South Korea, we can go do that. There it is. And it looks and feels the same because it is the same code that we ran in our Windows app and also on the web. This app also has native integration, so it can show the little .NET bot up there in the tray. We can click on him and trigger a native notification. By building our app as a Blazor hybrid app with .NET MAUI, we get the best of .NET, the web, and the underlying native platform.
Thanks for the awesome tour, Dan. We're working on a bunch of productivity improvements everywhere that will help you build and debug your apps much quicker. We commonly refer to this as the inner loop. It includes build time performance improvements in both the CLI as well as Visual Studio. You can see here that ASP.NET build times have significantly improved as compared to .NET 5. We're also working on bringing hot reload technologies to all project types. That means you can make UI and code changes while running and your app will immediately refresh. No more death by 1,000 F5s. No more start, stop, make a change, repeat. There's no process restart, so the state of your app is maintained. And you can optionally attach the debugger. Dimitri's going to dive deeper into how hot reload will improve your productivity no matter what type of app you're building.
Hello folks, my name is Dimitri Lylan and I'm a program manager on the .NET team. Today I'm going to tell you all about a new capability of .NET called .NET Hot Reload. This is a feature we've been working on for quite some time and we're really excited to share it with you. So let's jump right in. But before I explain Hot Reload, I have to give you a bit of context. So let me start with something that's more traditional by putting just a breakpoint inside of my running application. And in a method that's actually running, so we hit the breakpoint right away. I'm going to zoom in and point at one thing, that this code right here is now editable at the breakpoint, and this technology is called edit and continue. It's been in Visual Studio for quite some time, and it's something that I'm sure many people have been familiar with, or at least have tried once or twice. So what we're doing, starting with .NET 6 and newer versions of Visual Studio, is bringing that same capability not just to the paused application, but to the running application. Let me explain exactly what that means in a practical sense. So first of all, we've added a new button to the UI in the top. This new button called Apply Code Changes lets you apply changes to your running app without pausing or without having to be on a breakpoint. So let's actually do that to the application. Here the app is running, it's not paused, and I'm going to change one of the rules of the app. I'm going to change the speed limit. So by hitting the Apply Code Changes button, you can see the rules of the game are changing quite drastically in terms of the movement on the right-hand side. I can make that movement even more wild by making another change and applying that change as well. And as you can see, all of those changes are applied without having to stop the app. And if I undo the changes, well, I can just undo the changes right here, hit Apply Code Changes again, and everything's back to normal. So here you can see the power of Hot Reload in the sense of what it can do for you as your application is running. But let's switch to a more real scenario with a weather app that we have as a demo, so I can show you additional things that you can do here as well. Right, so here is the weather app, and this app is also running, the debugger is attached, and here's the app itself. So this app happens to be a .NET MAUI WinUI app, but I just want to be clear. Hot Reload is going to work with all kinds of applications. It's going to work with WPF, Windows Forms, ASP.NET, and many other application types. So whatever your app is, you can probably use Hot Reload to make your app better. So let's jump in and see how we can make this WinUI app better as just an example. So first of all, we think people will do changes such as this one, where maybe you started your app and you realized, oh, there's something here that you wanted to do, but you didn't quite do yet. So let's actually go ahead and show you what that could feel like. So here, I completely forgot to write a method to set the wind direction. So I'm going to go ahead and add that code to the application. So now there is a get direction method. It's just randomly creating values, but it's going to make my app animate, which is what I wanted to do before I ran it originally. And of course, you have to implement the code in the update live wind method. And this method is being re-executed over and over again on a timer. So my code changes that I just made will be re-executed when they get applied to the app. So now I hit apply code changes, the method behind the scenes gets re-executed, and now this starts to move. So that's one kind of change we can imagine you doing with .NET Hard Reload. Let's look at another potential change. I'm going to go to this home view model. And that's the view model that generates a lot of the data you see in the application. Now we're faking the data, so it's hard-coded because, this application is early in its development lifecycle. But another kind of change I could imagine doing when the app is running is deciding that this data isn't really doing justice to what I want to do, which is test the application as I build it. I would love for this data to be slightly more random to see if it causes any problems with the UI of the application. So I'm going to go ahead and actually do that. I'm going to get rid of pretty much all of these. I'm going to go and let's start here and go up and just leave one example, right? So if I hit apply code changes and I go back to my app and I navigate off the page and then back on the page, which causes the code to re-trigger, I now have only one daily forecast. But let me add a bunch of code right here that will actually generate a bunch of fake weather forecasts. And in this case, let's say I want to build 13 more of them. So I'm going to go hit apply code changes, switch here, go back, and now I should see a lot more data. Yep, a lot more data is up on my screen. And as you can see, some of it is actually going out of bounds. So now I know that my app has some visual bugs, and the only way I could have discovered it is if I put some kind of better, more randomized data into the applications with different kind of low and high values, and I could do all of that without ever stopping the application. Now that's not all. Imagine you want to do even more. You have a bunch of code that maybe you've not implemented in something. Like I'm going to go to favorites, and here I'm just missing a lot of code, it seems like at least. So let's go to that. I have certain properties implemented. I have a service that's being created here, but I have none of the logic to actually load the data. So if I come here and I put that code in and I hit apply code changes and I go back and I come forward again, as you can see, the data starts loading, at which point I'm going to notice something kind of strange. Redmond in every single box. Well, that's not right. Oh, look at that. There's like a little code error here. I should have had an I instead of 0. So now I'm going to apply the I, and I'm going to reload this again. And once again, it's going to fix the UI for me, and I can see the right data being loaded as expected. Now, as you just saw, we've made quite a few code changes without ever having to restart the application. And that's exactly why we're building .NET Hard Reload. In the real world scenarios, building an app can take quite a long time, even in a quick restart. And we hope that this technology saves you a lot of restarts and therefore makes you more productive. And the good news is this technology will be amazing with the debugger. It's going to be available in the F5 scenario of Visual Studio. And it's also coming in future releases to things like Control F5, where you won't even need a debugger attached if you choose not to use it, and will be available in kind of its simplest form inside of the CLI. So if you want to use the CLI, you'll be able to change code files as you go. But it, of course, will be best in Visual Studio. So we hope you give it a try. Thank you so much for watching.
Thanks, Dimitri. That was great. .NET 6 Preview 4 is available now, and previews drop every month until we release in November. I highly encourage you to download and check it out. We showed you C# 10, .NET MAUI, Blazor desktop apps, and some of the work we're doing to make cloud-native development much simpler. But there's a ton of other great features coming as well. Download .NET 6 Preview 4 and try it out today. I also want to call out that ML.NET, our open source cross-platform machine learning framework, has some new capabilities releasing today as well. ML.NET's newest update brings even more cross-platform support, including the ability to train and consume ML.NET models on ARM64 and M1 devices. The Model Builder's new config-based training introduces save progress and state. You can generate multiple models in one solution and collaborate on the same ML.NET project, whether that's in Visual Studio, on Windows, or in the ML.NET CLI on Mac OS or Linux. The team has been working on several perf improvements for Model Builder, so you can now quickly load large data sets. We have also been collaborating with the Microsoft Research to integrate state-of-the-art AutoML tech in the framework. And I'm finally excited to announce .NET Conf 2021 will be November 9th through the 11th, where we will launch .NET 6. Like always, this 3-day virtual event will go deep into all the things you can do with .NET. We have tons of sessions from the product teams at Microsoft, as well as the community. Keep an eye out for a call for content coming soon, and learn more at .NETconf.net. Save the date. I hope I got you excited about .NET 6 today. Please download .NET 6 Preview 4 and give it a try. And if you want to learn more, please visit our blog to read all about Preview 4. Thank you for watching.